We are up to part 2 of chemical equilibrium. And here is the beginning of it. And I am Ms. Bedrosian. How exciting is that? I first want to just remind you of what we left you with at the end of part 1, which was the equilibrium expression, which is the products to their coefficient over reactants to their coefficient. Remember, we exclude solids and liquids. If K is greater than 1, you can see that products are favored, obviously. And if it's less than 1, then reactants are favored. You can tell that just by looking at the equation. So we are going to go right to an example in a moment. When reactants are first mixed together, or at any point when they are mixed together and you happen to look in the container, it's helpful to know which way the reaction will proceed, either towards products or reactants. And this could be at any time before it reaches equilibrium. The reaction quotient, Q, is used as a sort of intermediate assessment of what's going on, using the initial concentrations or concentrations when it is not at equilibrium yet. So if Q is greater than K, it is the reaction is moving towards the reactants or to the left. If Q is less than K, it's moving towards the products. And if Q is equal to K, then you know the system is at equilibrium. So let's go to this example. For the synthesis of ammonia at 500 degrees Celsius, K is equal to 6.0 times 10 to the negative 2. Figure it out if the reaction will shift towards reactants or products. You're solving for Q, in other words. Step 1, always the same. What is it? Yep, write that balanced equation. In this case, all species are gases. You can stop the program, or you can see the equation. Here it is. Step 2, what is it? What's step 2? All right, step 2 is you're going to write the equilibrium expression. No numbers when you first write it. So you can pause and do that, or watch it come up. Here it is. Remember, it's products over reactants to their coefficients. Step 3, I am not solving for it. You plug it in. You figure out Q. So you plug in the numbers, solve for Q, and then make a determination as to which way this reaction is moving. Here comes the answer, or you can pause. And the answer for Q is 2.0 times 10 to the negative third. How does that relate to K? Make a determination how it relates. It is less than K. Therefore, the reaction is moving which way? The system will shift towards products. Make sure you understand how Q and K relate to each other. This is end of part 2. And in the next part, we will look at solubility constants. We are up to part 2.